now listening to Cassphere Podcast.
Welcome back to Cassphere,
Back again.
where we talk about AI news, technical knowledge.
And everything in life.
I'm your host, Truffle.
And I'm Olive.
You know, last time we dove into the world of some real AI heavyweights.
Oh, yeah.
People like Sam Altman, Jeffrey Hinton,
Fei Li.
and Ilya Sutskever.
Big names.
Today we're focusing on another giant in the field.
Huge.
Someone who's been called the Godfather of AI. Yann LeCun.
LeCun, yeah. His work is fascinating.
Really foundational.
Foundational, yeah.
He essentially gave computers eyes
That's a good way to put it.
with his development of convolutional neural networks, or CNN.
CNNs, right?
Something we might take for granted now.
Yeah, for sure.
But back in the late 1980s,
Well, right. 80s.
this was a revolutionary idea.
Revolutionary.
Okay, let's unpack this.
All right.
So who is Yann LeCun?
Who is he?
And what's the story behind his fascination with artificial intelligence?
Well, like a lot of us, who grew up fascinated by science fiction.
Yeah.
LeCun was really inspired by the movie 2001, A Space Odyssey.
Oh, classic.
That's right. The idea of intelligent machines just really captured his
I
imagination.
can be that.
Yeah, and that early spark, it led him to study engineering in Paris
Okay.
and eventually earn his PhD in computer science.
So from sci-fi fan to computer scientist, that's quite a journey.
Quite a journey.
And today, he's wearing a lot of hats in the AI world, right?
Absolutely. He's currently a Silver Professor at NYU,
Wow.
Chief AI Scientist at Meta,
Okay.
and was the founding director of Facebook AI Research.
Better known as FAIR.
Better known as FAIR, that's right.
That's impressive.
Yeah.
And speaking of impressive, he's also a Turing Award winner.
Turing Award, wow.
That's like the Nobel Prize of Computing.
That's right.
He shares that honor with Hinton and Bengio,
Mhm.
who we've discussed in previous deep dives.
Yeah, we have.
But let's get to the heart of it. What makes LeCun's work so groundbreaking?
His most significant contribution
Yeah,
is undoubtedly the development of CNNs.
those computer eyes.
Those computer eyes, right?
I mentioned earlier, before CNNs,
Uh-huh.
computers struggled to understand images the way we do.
They couldn't really make sense of visual patterns.
So how did CNNs change that?
Well,
I mean, I know they're used everywhere now, from facial recognition on our phones to self-driving cars.
that's right.
But what was so revolutionary about them back then?
Imagine you're trying to teach a computer to recognize a cat.
Okay.
You could show it thousands of cat pictures,
Uh-huh.
right, and label each one, but that's incredibly time-consuming and
Yeah.
inefficient.
For sure.
Plus, the computer wouldn't truly understand what makes a cat a cat.
Right.
It would just be memorizing patterns.
Right, I get that.
Yeah,
It's like the difference between memorizing a list of facts and actually understanding the concept behind them.
exactly.
Oh.
LeCun's brilliance was figuring out how to make computers learn those concepts by themselves.
Okay.
So CNNs work by using filters
Okay.
that scan across images, looking for specific features like edges, shapes, and textures.
Interesting.
And as they process the image, these filters create a hierarchy of features,
Okay.
gradually building up a more complex understanding of what they're seeing.
So instead of needing us to label every single cat picture,
Mm-hmm.
the CNN can figure out the defining features of a cat on its own.
Exactly.
Hmm.
That's why it was such a game changer.
Yeah.
Suddenly, computers could see and interpret images in a way that was much closer to how humans do it.
Right.
And this opened up a whole world of possibilities for AI applications.
It's amazing how one idea can have such a ripple effect.
It really is.
But it sounds like LeCun's contributions go beyond just CNNs, right?
Absolutely.
I know he's done a lot of work in other areas like optical character recognition or OCR.
Oh, yeah, OCR.
Yes.
In fact, one of his early successes was developing a system that could read handwritten checks.
Really?
Yeah, back then, banks had to process mountains of checks manually,
Oh, I can imagine.
which was slow,
Yeah.
expensive, and prone to errors.
Of course.
So LeCun basically automated that whole process.
No more humans deciphering bad handwriting.
Pretty much.
Wow.
His OCR system was a huge leap forward in automating this task.
Yeah.
And it's the same technology that allows our smartphones to understand our handwriting today.
That's pretty incredible when you think about it.
It is, yeah.
It's easy to forget how revolutionary these seemingly simple features were when they first came out.
Right.
But didn't he also develop something called DGVU?
DJV.
Yes, I've seen that on websites with old documents.
Yes, DJV is another one of LeCun's innovations.
Cool.
It's a method for compressing scanned documents so they can be shared online without taking up huge amounts of storage space.
So it's like the technology behind digital libraries and archives.
Exactly.
Right.
Websites like the Internet Archive
Yeah.
rely heavily on DJView to make vast collections of books and historical documents accessible to everyone.
It's amazing how he's made such significant contributions across different areas of AI and computer science.
He's a pioneer.
I'm really curious to hear more about what he's up to now.
Well, that's where things get even more interesting.
All right.
LeCun's current work at Meta is pushing the boundaries of AI in some really exciting ways.
Okay.
He's not just focused on making AI better at specific tasks.
Right.
He's trying to figure out how to make it more generally intelligent.
That's a pretty ambitious goal.
It is, but before we dive into that,
Okay.
I think it's important to understand some of the more technical concepts he's explored,
Okay.
like backpropagation
Backpropagation.
and optimal brain damage.
Those sound kind of intimidating, to be honest.
They do, don't they?
Yeah.
But they're actually not that complicated once you break them down.
Okay.
Backpropagation is a fundamental algorithm in machine learning.
Okay.
It's how neural networks learn from their mistakes.
Okay, so it's like a feedback loop that helps the network adjust its parameters and improve over time.
Precisely.
All right.
Think of it like practicing archery.
Okay.
Each time you miss the target,
Yeah.
you slightly adjust your aim. Right.
Based on where the arrow landed.
I get it.
Backpropagation does something similar for neural networks.
That's a helpful analogy.
Great.
But what about optimal brain damage?
Optimal brain damage.
That sounds a bit alarming.
It's a rather dramatic name,
Yeah.
I'll admit, but it's actually a technique for making neural networks more efficient.
Right, so you're damaging the network to make it better.
Right.
How does that work?
Think of it like pruning a tree.
Okay,
You remove unnecessary branches
Yeah.
to allow the healthy ones to grow stronger.
I see.
LeCun's research showed that you can selectively remove certain connections
Mhm.
within a neural network without sacrificing its performance.
Interesting.
This makes the network smaller, faster, and more efficient.
So it's about streamlining the network, making it leaner and meaner.
Exactly.
Like that.
Good.
What about energy-based models?
Energy-based models.
I know he's done some work in that area, too.
Yes, energy-based models are another fascinating area of his research.
They're a type of probabilistic model
Okay.
used for tasks like object recognition.
Uh,
They learn to represent the world in terms of energy landscapes.
energy landscapes.
Yeah, where low energy states correspond to likely configurations of data.
That sounds pretty abstract.
It does, yeah.
Could you give me an example of how that works in practice?
Okay, imagine you're teaching a computer to recognize different types of fruit.
All right.
An energy-based model would learn to represent each fruit as a point in a multidimensional space.
Okay.
Fruits that are similar to each other, like apples and oranges, would be clustered closer together,
Okay.
while fruits that are very different,
Yeah.
like bananas and grapes,
Right.
would be farther apart.
I see.
And the model uses energy levels to determine how likely it is that a particular object belongs to a certain category.
So it's about finding patterns and relationships based on how similar or different things are.
Exactly.
Okay.
It's a more nuanced way of understanding the world
Yeah.
than just looking at individual features.
So it's like the model is creating a mental map of all the different types of fruit,
Right.
and it can use that map to figure out what a new fruit is based on where it fits into that map.
That's a great way to put it.
Okay.
It's a more holistic approach to object recognition.
Yeah.
And it has a lot of potential for applications in AI.
It's clear that LeCun has been a pioneer in so many different areas of AI,
Yes.
from the fundamental algorithms to the ways we apply them.
Yeah.
But I'm really interested in hearing more about his current work at Meta
Okay.
and his vision for the future of AI.
All right.
So what exactly is LeCun's vision for the future of AI? What's he trying to achieve at Meta?
What's the core ideas driving his vision is something he calls autonomous intelligence.
Autonomous intelligence. What's that all about? Is it the same as artificial general intelligence, or AGI, which seems to be all over the news these days?
It's related, but not quite the same. AGI is a very broad concept, the idea that we can create AI systems that can perform any intellectual task a human can. LeCun thinks that's not necessarily the right goal, at least not yet.
Interesting.
Yeah.
Why not? Isn't AGI kind of the holy grail of AI research? A lot of people seem to think so.
It is for some. But LeCun argues that AGI is too vague and too far off right now. He's more interested in developing AI systems that can learn and adapt on their own within specific areas.
So instead of trying to replicate the full range of human intelligence, he's focusing on creating specialized AIs that are really good at particular tasks.
Exactly. Think about it. We don't expect a single person to be an expert in everything: medicine, engineering, music, and so on. We specialize. LeCun believes AI should do the same.
That's a good point. So what kind of real-world applications does he envision for this autonomous intelligence?
The possibilities are vast. Imagine self-driving cars that can navigate really complex environments, not by just following a set of rules, but by truly understanding their surroundings like a human driver would.
That would make self-driving cars much safer and more reliable.
Exactly. Or imagine robots that can assist with complex tasks in factories or hospitals, learning and adapting to new situations without needing constant human intervention.
It's like AI that can think on its feet and solve problems without needing us to hold its hand every step of the way.
That's the idea. But of course, there are some significant challenges in developing this kind of autonomous intelligence.
Like what? What are the biggest hurdles LeCun is trying to overcome?
One of the biggest hurdles, according to LeCun, is moving beyond the limitations of supervised learning, which is how most AI systems are trained today.
Right, supervised learning is where you feed the AI a ton of labeled data, like showing it millions of pictures of cats and telling it, this is a cat.
Exactly. But LeCun argues that this approach is inefficient and doesn't allow AI systems to develop a true understanding of the world.
Because in the real world, we don't learn everything through labels. We learn by observing, experimenting, and figuring things out on our own, right?
Precisely. Think about how children learn. They don't need someone to label every object they see. They learn by interacting with the world and making connections.
So LeCun is trying to develop AI systems that can learn more, like humans do.
That's the goal. He believes that the key to unlocking autonomous intelligence lies in something called self-supervised learning.
Self-supervised learning, what's that?
It's a type of machine learning where the AI system learns from unlabeled data. It figures out patterns and relationships on its own without needing explicit instructions.
So instead of us telling it, this is a cat, we let it loose in a world full of data and let it figure out what a cat is by itself.
Exactly. It's more about letting the AI explore and learn from its own experiences, just like a child playing with blocks and figuring out how they fit together.
That sounds pretty revolutionary. But why is LeCun so convinced that this is the right path for AI?
He believes that self-supervised learning will allow AI systems to develop a much deeper understanding of the world. Instead of just memorizing patterns, they'll be able to reason, plan, and make decisions based on a more holistic understanding of their environment.
So AI that can actually think for itself and not just follow our instructions? That's pretty exciting, but also a little bit scary if you think about it.
It's definitely a big leap, and it raises a lot of questions about the future of AI and its role in society. But LeCun is optimistic. He sees AI as a powerful tool that can help us solve some of the world's most challenging problems.
So it's not about AI replacing humans, but about humans and AI working together to achieve greater things.
We're wrapping up our deep dive into the world of Yann LeCun.
We've talked about his journey from being inspired by 2001, a space odyssey,
to becoming a leading figure in AI research,
we've explored his groundbreaking work on convolutional neural networks,
which, as we've seen, revolutionized how computers see,
and we've delved into his vision for autonomous intelligence.
and how that could really change the way we live and work.
Absolutely. That's it for our deep dive into the world of Yann LeCun.
Until next time, keep exploring
Keep questioning.
and keep learning.
From all of us here at Cassphere, goodbye.